Describe the pattern of association between the variables in each scatter plot. For this first one, we can say that there is a strong, negative because it's going down, linear because it appears to create a straight line, you will need to describe the association you see in problem 2, problem 3, and problem 4. The scatter plot shows the sizes of prices of 16 houses for sale in a Midwestern city. How much do you think the price of a 3,000 square foot house might be? Explain your reasoning. So if we went to 3,000, we would want our data to fall along this trend. So 3,000, I would expect it to be somewhere in here, which is like $450,000. Draw a line in the scatter plot that you think fits the pattern of data. So if we took a straight edge and drew a line through here, we want it to follow the pattern of data. So it should follow most of the points. Then the next part says to use your line to predict the cost of a 3,000 square foot home. So if I use that line here, you can see 3,000, and that is 500,000 on the line. D says to use your line to predict the price of a 1,500 square foot home. Here we see 1,500 is about $200,000. Four students use different strategies to fit a line to the data in the scatter plot. Determine whether each strategy results in a line that fits the data well. Explain your reasoning. Maya starts a line from the farthest left point to the farthest right point on the scatter plot. Well, that doesn't appear to follow the pattern of data. You can see that most of the points are below the line. Some points are close to the line, but others are far from the line. Pedro draws a line that has the same number of points above and below the line. This also does not fit the data well. Pedro's line is horizontal, but the data has a downward trend. Ava draws a line that passes through as many points as possible. This does show the downward pattern, but it does not fit the data well. Even though there are 3 points on the line, it does not follow the pattern of association, and many of the points are not even close to the line. Ethan draws a line that is as close as possible to all of the points in the scatter plot. This strategy is the best strategy. That fits the data. It follows the pattern. Some points are above. But all of the points are as close to the line as possible. Not very far away. They're pretty close to that line. Which line best demonstrates Ethan's strategy from problem 2? Explain. Well, A has the line too far below many of these points. B does not necessarily follow that pattern. C looks pretty good. D has too many below the line. So I would say that C is the best. Nora fits a line to the data in the scatter plot. If Nora uses the line to make a prediction, is her prediction likely to be too high or too low? Explain. Well, her prediction is likely to be too low because it's lower than most of the data points in the scatter plot. Five, the table shows the speed of the Columbia River at 11 different depths. So it might go faster in one spot based on depth or slower in another spot. Use the scatter plot to describe the association between the depth and speed of the Columbia River. Then identify any outliers or clusters. So this isn't a very strong correlation or association, but there is a moderate association here. We need to make a note of the association. So we would say it is a negative linear association. You might say that this point is an outlier because it lies outside of the typical data set. Oops. And that is the point 2, 1, 11 as an outlier. But there don't appear to be any clusters. Remember, the clusters are those big clouds or groupings of points. Then it says fit a line to the data in the scatter plot. How does the slope of the line you drew relate to the direction of the association? So we want a line that goes through the majority of the center of the points, trying to get as close to as many as possible. So it might look something like this. Yours may not match mine perfectly, but the slope of the line is negative, and we said that it was a negative linear pattern. Use your line to predict the speed of the river at the depth of 5 feet. So we went to 5 here. We could say that the depth is around 1.1. Again, this is just an approximation based on our line. And that was measured in feet per second. Use your line to predict the speed of a river at a depth of 8.6. Compare your prediction with the actual speed at that depth. So 8.6 to 6 is around here. And that appears to be around 0.65. Again, this is just an approximation. The actual speed at that depth was 0.59. You can see that result from the table. So my prediction is greater. Consider the depths 4.6 feet and 9.9 feet. At which depth is the speed predicted by your line closer to the actual speed? Explain. So here at 4.6, you can see that my dot at 4.6 is quite a ways from my line. And then at 9.9, right around here, that dot is closer to my line. So at which depth is the speed of the line, speed you predicted by your line closer to the actual speed? It is closer at 9.9 feet. that point from the table was 4.6, 1.39, is farther from the line than the point 9.9, 0.59. At which depth is the speed predicted by your line farthest from the actual speed, and how can you tell? So let's go back and look at that line from the previous slide. The farthest point is this one here. You can see that that is a pretty significant distance away from that line, and that was the point 2, 1.11. Six, draw a line that fits the data in the scatter plot. We want it to be close to as many points as possible. Seven, the scatter plot shows the same data as problem 6 with an extra point at 8:10. Draw a line that fits the data. Okay, so now we have a point that's going to create a line going this direction. It says in problem 8, did the outlier in problem 7 influence the line you drew? Explain. Well, yes, that outlier changed the direction of our line. When we include the outlier, it went from having a negative slope to a positive slope. So an outlier can impact or influence a line of best fit, also known as a trend line. If it's outside of the pattern, it can change the direction of the line. An outlier has a large influence on the line that fits the data or that is far away from the main clusters. That is the end of lesson 13. Check back for more Module 6 videos in the playlist.